Hi there, my name is Naurah with the Mentic number 155256. I am a first year student from the School of Physics, majoring in pure physics, and today I will be your presenter.
Assalamualaikum and hello everyone. My name is Khalida Aliya binti Amran. I'm a first year student from School of Educational Studies with major in physics. My contribution in this group as a script writer.
Assalamualaikum and hello everyone. My name is Nabilah binti Omar. I'm from School of Physics, majoring in pure physics. In this video, I'm the editor.
Now, magnetism. I don't know about you, but I've heard all about its application in our daily lives, bounded by the walls of our planet Earth. But in today's video, we're going to reach high and beyond and explore our universe through magnetism. But first, how did we know that there are magnetic fields out in the universe, and how are they mapped? Well, like Earth, galaxies also have magnetic fields, but galactic magnetic fields are way too weak compared to the magnetic field of Earth, although they are probably generated the same way through the dynamo effect. To put it simply, the spaces between stars or the interstellar medium is full of gas consisting of charged particles that will generate magnetic field, and it imitates the motion of the galaxy itself, so that's why the pattern of magnetism usually copies that of the galaxy. But let's look at it in more detail, shall we? In our Milky Way, the interstellar medium is scattered with tiny specks of dust that come from past supernova explosion. For your information, supernova is a powerful stellar explosion in which a star becomes very bright and bursts, causing its matter to scatter in all directions, with its light and radiation shooting out. But back to the topic at hand, these specks tend to align with the magnetic field of the local galaxy, similar to how iron filings follow the magnetic field of a bar magnet. So when light passes through the interstellar medium, it would have been scattered by this grain and bounces off of them, but their alignment in the direction of magnetic field polarizes the light instead. This means that the electric and the magnetic component of the light pick up a preferred direction rather than being random. Through this phenomenon, scientists can measure the polarization and map out the magnetic field of the Milky Way. Now, isn't that impressive? And it sounds simple, right? But in reality, scientists put a lot of work into mapping the magnetic field of the galaxy, and this is proven through the Planck's mission. The Planck's mission is a mission done by the European Space Agency to detect the most ancient light in the history of our universe, which is the cosmic microwave background. In this mission, the polarized emission of interstellar dust is used to reconstruct our galaxy's magnetic field and to study its role in the buildup of structure in the Milky Way. This image is the visualization of data from the European Space Agency's Planck satellite. As you can see, the arrangement of magnetic field is more ordered along the galactic plane, which is an imaginary plane that cuts our galaxies in half top to bottom, where it follows the spiral structure of the Milky Way. Small clouds can be seen just above and below the galactic plane, where the direction of magnetic field is less regular. It's also important to note that the bluer regions indicate stronger polarization, and the striation indicates the direction of magnetic field. On the observation of this mission, we can say that the filamentary interstellar clouds are preferentially aligned due to polarization with the direction of the ambient magnetic field, and this highlights the strong role played by magnetism in galaxy formation. Okay, so there are magnetic fields in the universe, but why are they there? Well, you'll be pleased to know that cosmic magnetism plays a big role in creating stars born in dense interstellar clouds. Let me tell you how it's done. Firstly, gas begins to clump together into a protostar, which is a very young star that is still gathering mass from its parent molecular cloud. Then, it goes dense enough until it collapses under its own gravity, before becoming a full-fledged star when it starts fusing hydrogen into helium in its core. The issue here is trying to explain stellar birth through gravity alone is impossible, because if gravitational force was the only force at play, then the protostar would rotate itself faster and even faster before it could even reach the mass similar to our Sun. So, astronomers now think that the strong magnetic field in this gas cloud create a drag on the protostar, allowing it to gain enough mass and ignite. Guys, do you know that magnetic fields also facilitate star formation after stars die? Let me explain. Bear in mind that every supernova explosion is accompanied by magnetic blasts. These blasts help to compress gas in the direction of the explosion, triggering bursts of new star formation. The same supernova can also blast out the entire guts into the galaxy, which means that the newly formed elements should have been gone missing in space. Luckily, galactic magnetic fields constrains that flow, funneling some of it into the galactic fountain erupting from the poles. These galactic fountains play an important role for building galaxies. Its material tends to spill into space around the galaxy before raining back in, where it can be used for new star formation, all thanks to magnetic field. So, everything considered, what are the advantages and drawbacks about cosmic magnetic field? Well, obviously from before, we know that cosmic magnetism is crucial for various formation of space objects. Without it, we wouldn't have our favorite stars or galaxies, and the materials in space would just be scattered everywhere aimlessly. On the other hand, there are still so many mysteries remain in understanding cosmic magnetic fields. One of the questions would be, what creates them in the first place? Scientists have considered that some sort of dynamo mechanism is at play, similar to how Earth produces its magnetic field, but they are unsure of how long it took the field to form and how rapidly they gain strength, and thus preventing us to make more use of it. In conclusion, magnetism goes beyond our planet and through the edge of the universe. It's important for us to understand and learn about cosmic scale magnetic fields too, because without it, Earth may not even exist. Anyways, that's all from us in this video. We hope you had fun learning about universe today. And until next time, goodbye!